In today's lesson, we will be learning how to perform long division on polynomials. So we're going to take a look at the first slide. The first set of examples deals with taking a polynomial, which we can see in the numerator, and divided by a monomial, which means one term, which we can see in the denominator. The way to perform this is to actually take every term that's in the numerator and divide separately by the denominator. So what this means is we'll split it up into three separate fractions. One, where it is 6r squared over 3rs plus 3rs squared over 3rs minus 9r squared s over 3rs. And then we just perform our properties of exponents to simplify each fraction separately. In the first fraction, we see that 6 divided by 3 is 2. R squared divided by r, one of the r's cancels, so we're left with the r. And then s squared divided by s, one of the s's cancel, and we're left with s. Plus 3 divided by 3 is 1, so these cancel. R divided by r is 1, and s squared divided by s, one of the s's cancel, and we're left with just s. Last fraction, 9 divided by 3 is 3. R squared divided by r, one of the r's cancel, so we're left with r. And then s divided by s is 1. So then our final answer is 2rs plus s minus 3r. And we can apply the same idea to the second problem, where we're going to take each term in the numerator and divide separately by the monomial in the denominator. So really we'll have 8x cubed y squared over 2xy squared minus 4xy to the fourth minus 2xy squared minus 2xy over 2xy squared. And then we do our properties of exponents and simplify from here. We see that 8 divided by 2 is 4. X cubed over x is x squared. Y squared over y squared cancels. And so minus 4 divided by 2 is 2. X divided by x cancels. And then y to the fourth divided by y squared is a y squared in the top. And we have 2 divided by 2, which cancels. X divided by x cancels, and so then we have a y on top and a y squared at the bottom, so one of the y's in the top cancels, and we're left with still one y in the bottom. And since everything in the top canceled, we are left with the number 1. So then our final answer is 4x squared minus 2y squared minus 1 over y. So for these examples, we're going to look at how to divide a polynomial by a binomial using long division. So we see in the first example, we have c squared minus c minus 30 divided by c minus 6. So the first thing that you want to do is set it up as a long division problem. So the c squared minus c minus 30 goes in the long division bar, and then our c minus 6 goes on the outside. Now what we want to do is first look at how many terms we have. And we see that we have 2 terms, so go over 2 terms. So our first answer is going to be right above this c. And then we look at the first term. What do you multiply c by to get c squared? And you would multiply c by c to get c squared. So that c goes above here, and then you distribute c times c gives you c squared. C times negative 6 gives you negative 6c. And like you do with regular long division, you subtract the entire expression. So that entire expression goes in parentheses, and you perform. So c squared minus c squared is 0, so these cancel out. You have negative c minus a negative 6c. So minus negatives like doing addition, so negative c plus 6c is 5c. Drop down the minus 30, and you repeat the process again. You look at the first term, and you see what do you multiply c by to get 5c, and that would be a positive 5, so plus 5 goes up here. Distribute 5 times c is 5c, and 5 times negative 6 is negative 30. Subtract that entire expression. 5c minus 5c is 0. Negative 30 minus negative 30 is 0 as well. That 0 represents your remainder. And so since we have a remainder of 0, our final answer is just whatever is left on the top of the long division, which would be our c plus 5. So that is our final answer when you divide c squared minus c minus 30 by c minus 6. So let's take a look at the second example. We have s squared plus 4s minus 16 times s minus 6 to the negative first. Now remember, when you raise something to the negative first power, that actually means it goes to the opposite side. So here it means if you go underneath a fraction, so it'd be the denominator, so we're actually dividing by s minus 6. So we have s minus 6 on the outside and our s squared plus 4s minus 16 on the inside of the long division. And so we end up doing the same thing, following the same algorithm from this point. We see we have two terms, s minus 6, so go over two terms. So our first answer is going to be written above the 4s. And then we look at what do you multiply s by to get s squared, and that would be s. And distribute s times s is s squared, and s times negative 6 is negative 6s. So we do our subtraction of the entire expression inside parentheses. And so we see that s squared minus s squared is 0. 4s minus a negative 6s is like doing addition, so you get 10s. Drop down the minus 16. And then we look at the first term. What do you multiply s by to get 10s? And that would be a positive 10. Distribute the positive 10. 10 times s is 10s. And 10 times negative 6 is negative 60. Subtract the entire expression. Our 10s minus 10s cancels. And negative 16 minus a negative 60 is really like doing addition. So negative 16 plus 60 is 44. And just like before, that 44 represents your remainder. Now that we have a remainder that's non-zero, we have to set this up a little bit differently. You still do the same thing as before. Your answer is partially that s plus 10. And the rest of your answer includes the remainder. So this is a positive 44. So put that in a numerator. And the denominator is what you divide it by. And we divide it by s minus 6. So then our final answer is our s plus 10 plus our remainder, which was 44, over what we divided by, which was s minus 6. In example 3, we notice that we have x to the fourth minus 2x cubed plus x minus 1. Now, in this example, it's different because we're missing a term here. Our powers go from x to the fourth to x cubed and skips the x squared power and goes just to x minus 1. So what we need to learn and what we apply when we're doing long division is that we must always include a 0 for this one would be the x squared term, but any missing term you include a 0 for. So we take a look. That means we would have our x to the fourth minus 2x cubed, and we're going to have to insert a 0 x squared. So this is what our division would look like. We have x to the fourth minus 2x cubed plus 0x squared plus x minus 1. And we're dividing by x plus 1. So again, we look, what do we multiply x by to cancel out x to the fourth? And that would be an x cubed. Distribute x cubed times x gives you x to the fourth. And then we have x cubed times 1 gives us x cubed. We subtract the entire thing. The x to the fourth cancel. We have negative 2x cubed minus x cubed, so that's negative 3x cubed. We drop down our 0x squared. And again, we look at what we multiply x by to get negative 3x cubed, and that would be a negative 3x squared. Distribute, and we get negative 3x cubed. Distribute, we get minus 3x squared. Subtract the entire expression. Negative 3x cubed minus negative 3x squared cancels. 0x squared minus a negative is addition, so 0x squared plus 3x squared is 3x squared. Drop down the positive x. Repeat the process again. What do you multiply x by to get 3x squared? And that would be a positive 3x. Distribute the positive 3x, and you get 3x squared plus 3x. And then perform our subtraction. So the first term is going to cancel, and we really have 1x minus 3x, so that's negative 2x. And then we drop down our minus 1. Now what do we multiply x by to get negative 2x? And that would be a negative 2. Distribute negative 2 to both terms. You're going to get negative 2x minus 2. Subtract that entire expression. Negative 1, first term cancels. Negative 1 minus negative 2 is like negative 1 plus 2, which is 1. And again, that 1 represents your remainder. So then our answer for this problem is what is written on top, our x cubed minus 3x squared plus 3x minus 2. And since our remainder is positive, we put a positive 1 over what we divided by, which was x plus 1. So our answer is x cubed minus 3x squared plus 3x minus 2 plus 1 over x plus 1. In the fourth example, we have 6xt cubed plus 5t squared plus 9. And this, remember, is going to turn into division. It's 2t plus 3. So if we take a look, we notice again we go with our exponents t cubed, t squared, and then we jump to our constant, which means we're missing the variable t to the first power. So that means it's going to be time for us to again add a 0 coefficient like we did before, and this time we'll include it for our t term. So when we set up our division, we have our 6t cubed plus 5t squared plus 0t, our 0 for the t term, plus 9, and we're dividing that by 2t plus 3. So again, when we perform the division, we have two terms. Our first number is going to be written above the second term here. And we look at the first terms. What do you multiply 2t by to cancel out 6t cubed? And that would be a 3t squared. Distribute 3t squared to both terms, and you will get 6t cubed plus 9t squared. Subtract the entire expression. First term is going to cancel, so we have 5t squared minus 9t squared, and that would be negative 4t squared. Drop down our 0t. And if we take a look, what do you multiply 2t by to get negative 4t squared, and that would be a negative 2t. Distribute negative 2t to both terms, and you will get negative 4t squared minus 6t. Parentheses, subtract the entire expression. Negative 4t squared minus negative 4t squared, that cancels. 0t minus a negative, 6t, so minus a negative becomes addition. So 0t plus 6t is 6t. And then we drop down our plus 9. What do you multiply 2t by to get 6t? And that would be a positive 3. Distribute 3 to both terms, and we'll get 6t plus 9. Subtract. We have our 6t minus 6t, which cancels. And we have 9 minus 9, which is 0. And just like before, that 0 actually represents our remainder. And so our answer is what we have left in the top, which would be 3t squared minus 2t plus 3. And so that is our answer. Since we have a remainder of 0, we don't have to worry about any fraction at all. So let's try the last example. So when we look at this example, we have 2h cubed minus 5h squared plus 22h plus 51. Our polynomial is not missing any terms, so we can just leave it as is. And we are dividing by our 2h plus 3. So let's set that up in our division with our polynomial inside the long division and our 2h plus 3 on the outside. And we take a look, we have ourselves two terms. So go over two terms, and our first answer will be above that second term. And we take a look at the first terms. What do you multiply 2h by to get 2h cubed? And that would be an h squared. Distribute h squared to both terms, and you're going to get 2h cubed plus our 3h squared. Subtract the entire expression, and we get negative 5h squared. The first term cancels. Negative 5h squared minus 3h squared. So that would be negative 8h squared. Drop down our 22h. Let's fix that. So we drop down our 22h. And we take a look, what do you multiply 2h by to get negative 8h squared? And that would be a negative 4h. Distribute negative 4h to both terms, and you're going to get negative 8h squared minus 12h. Subtract that entire expression, which remember means that negative gets distributed to both terms. The first term cancels, and you get 22h minus a negative 12h. Minus negative means addition, so 22h plus 12h is 34h. Drop down our positive 51. And again, what do you multiply 2h by to get 34h? And that would be 17. Distribute, and you get 34h. And 17 times 3 is actually 51. Subtract the entire expression. And when we do that, the first term cancels, and you get 51 minus 51, which is 0. And as before, that 0 represents your remainder. So then our final answer is what we have on top, which would be h squared minus 4h plus 17. The assignment for this lesson is the 6.2 Skills Practice Worksheet, so that will get passed out after this recording. Also, for the sophomores in the class, please remember that your OGT 2007 practice test, both the multiple choice and the extended response, the free response, is due on block day this week. So you have to turn that in Thursday at the beginning of class. Remember that is a part of determining whether or not you can exempt the final exam based off of your OGT scores if you get the highest rating in advanced. So that is a mandated assignment that you must do as sophomores, so please finish that as well. And if you have any questions, just go online, watch some more tutorial videos that are there, and use the homework checks.